So we see how we can use Docker and Puppet together to make two things awesome, even more awesome. So first, who am I and why am I here? I'm a currently French DevOps. Nobody's perfect. And I was part of .cloud, the company who was Docker before Docker was Docker. So it was like the hipster Docker before it was cool. And there I was deploying things, and there was some Puppet stuff and some container stuff. So it kind of made sense that people thought I should talk about this. And I also contributed a few things into Docker, mostly because I want to run all the things in Docker, so network appliances, Steam games, an X server to run desktop applications, and of course database, web apps, and all the usual stuff. And I'm also officially part of the services and support team at Docker, which means that I help people to run Docker in production. So first, a little refresher about Docker. First, who has never heard about Docker? Okay. And who has heard about it but doesn't really know what it is? Okay, so the little refresher will be useful. Right. So the Docker platform is actually made of two things, the engine and the hub. The engine is what people use to just call Docker. It's this little thing that you can install and run and do stuff with. And the hub is the kind of the ecosystem around it that makes it more interesting from a value proposition point of view. So first, what's the Docker engine? The Docker engine is something open source, so it's free. You can get the source code on GitHub, and there is packages for virtually everything. And if you don't like packages, it's in Go, which means that there is a single binary that you can download and run, and so you don't even have to go to packages if you don't like that. And it's all about running containers. And it runs on any modern Linux machine, only on Intel 64 bits officially, but people have been running Docker successfully on 32-bit machine and on ARM and on other architectures as well. It's just not official. Containers. So what exactly are containers? Containers. So the mouthful wording is it's a software delivery mechanism. So it's a little bit like a package, except it comes with everything you need to run your application. It sounds a little bit like the Java thing. Compile once, run everywhere. Here it's package once, so put in the container once, and then run everywhere. It's a little bit like a virtual machine that you can take and copy somewhere, except that containers have at least 4 advantages over the machines. They boot faster. Containers typically boot in a few milliseconds, and then the app is immediately ready. They have less overhead, so people have done benchmarks showing that you could pack way more containers on a single machine than you could pack VMs. They have native performance, so if you run like HPC workloads and say, I don't even want the 5-person overhead of VM or something like that, containers can do that for you. And they are cloud compatible in the sense that you can run containers inside of VMs. So if you want to run containers on EC2 on some other public cloud, you can. While if you have a VM image and want to run that on EC2, it will be a little bit more complicated. So the Docker engine, to give kind of broad approximation, it's a little bit like the hypervisor that you use to run VMs, except that you run containers. And those containers are a little bit like VMs, but lighter, they use less resources. And the key point is that Docker did not invent containers or anything like that. It merely used technology that has been around for decades and made it really easy to use. So you don't have to be like a black belt ninja Unix guru to be able to use containers anymore. So a really quick demo, if all that stuff was confusing and didn't really make sense. So is this readable enough? Maybe not. Bigger. I don't know if I can make that bigger. It's okay. Maybe if I can do. Okay. Let's see if I can do something like. Wait. Have faith. Right. It's a little bit bigger, right?
Yeah. Better.
Okay. So there is a little command line tool with a bunch of commands. And basically, I start container with Docker run. So let's say I want Ubuntu, and I do this, and now I have a Ubuntu container. And okay, if I don't like Ubuntu, I want Debian, I can do that. Now I have a Debian container. It's like a brand new VM. If I don't like Debian, let's say I want CentOS maybe, I do this, and now I have a CentOS container. And as you could see, it started really quickly, and then I can see those running containers here. So that's like the basic interaction with Docker. Start containers, and it just works. And if I try to run something that I don't have locally, it will download it from the famous Docker Hub that I will introduce in a few slides. Okay, so now that I did that, I think I screwed up the slide, so I have to, let's see. So again, blue and black and green, then it will come back. Sorry about that. So the Docker Hub is a bunch of services that Docker Inc., the company, operates to make Docker more useful, more easy to use. So for instance, you can make your own images. So you can put your software in a container image, and then you can push that image to the Docker Hub, and then you can go to a different machine and pull down the image and run it. Those images can be public or private, depending on whether your code and binaries are something you want people to see, or if it's something for your own use. It also has something called automated builds, which means that you can link together your GitHub or Bitbucket account with the Docker Hub, and each time you push some code to a repository, it will build a container in a matter of seconds or minutes, depending on the complexity of the build. You will be able to run that container on your servers. And last but not least, it follows the GitHub model in the sense that it's free as long as it's for public code and public images, and you have to give money to run private stuff. But anyway, enough about that. Let's talk a little bit about building containers, because that's where it will tie with configuration management and therefore Puppet. The official way to build Docker container images is to use a Dockerfile. So a Dockerfile looks like this. In the beginning, we say from which image we want to start. So in that case, I want to start from basic Ubuntu 14.4. I have some comments here, and then the bug is here. It looks like a shell script. It says I have to apt-get update, apt-get install nginx, generate an index.html file, and then here I say that my service is running on port 80, and I say that by default, when I start this container, I want to execute nginx. And okay, bear with me just a second while we change again. So I have the very same Dockerfile here, and I will change it. I hello Chicago, and then this is how you build from Dockerfile. You give a name like static web, and you say build that directory. And it will run all those steps in sequence. And at the end, it tells me the container is built. And now I can run that container. Whoops, Docker run. And I can see, okay, it's here, but if I like that, we can see that my container has been started on that port here. And now I can point my browser to that container, and it works. Okay, that's not a very impressive demo. I'm sorry, we're going to do better next time. But the key idea was to show that with this simple file that hopefully everybody could understand just by looking at it, how we built a simple web container. And if we want to build something more complex, it will be much more complicated. This is, for instance, a Dockerfile to build a CouchDB container. So of course, there are more steps, there are more packages to install. Then we download the source code for CouchDB, and we extract it, and we configure and make install, and then the configuration file that we generate is a little bit more complicated because it has at least 3 or 4 lines, but at the end of the day, it's exactly the same thing. I put something in the container, I generated some configuration, I define on which port it is sent if it's something that is a port, and I build it the same way. So let's see how that compares to shell scripts, because why did we do that instead of the shell scripts? Shell scripts are nice for really simple stacks, because, well, usually that's what everybody starts to write when they want to automate. They do shell scripts. And even before that, they maybe have a legal yellow notepad and they write down the instructions and then give the instructions to the intern and tell them, okay, run that on the 200 production servers by tomorrow. And normally the intern at that point starts learning how to write shell scripts and do the SSH and things like that. And if he's particularly lucky, he starts to learn about configuration management. The problem with shell scripts is that it's difficult to handle all the possible situations. Maybe one step of the shell script is apt-get install some package, and that package conflicts with something that is already installed. Or maybe an older version of the package is already installed, so when you apt-get installed, it does nothing because it says, well, you already have OpenSSL, so I don't need to install it. And then you're stuck with an older version of OpenSSL. And also, when you automate with shell scripts, you have a tough decision to make. Either you redo everything from scratch each time you change something, and it takes forever to redo all the steps. Or you do a clever shell script that say, before installing like 400 megabytes of packages, I will check if those packages are already there just to make sure I don't do something useless. But then it means you have a different behavior when you start from scratch and when you start on already installed machine. So that's why people came up with configuration management like Puppet, Chef, Salt, and syslogd. So let's see the upsides of configuration management in that case. It deals with low-level stuff, so getting the really basic things in the machine that developers don't want to deal with. The basic packages, sometimes kernel, partitioning, all that stuff. It abstracts some details, like when you go from a major distro version to another, when you do like a big upgrade from 2 to 12 to 14, it still works, hopefully. It can even abstract between different distros, because when you say, I want the SSH server to be installed, the configuration management system will be able to translate that differently depending on whether you're on a Red Hat or a Debian or something else. Sometimes it can even do that between different operating systems. And it ensures convergence to a known state, which means regardless of the state of the machine, it will bring that to a known state where all the stuff that you want is here. Now, the problem with configuration management is that the learning curve is pretty steep. The first time I had to write a Puppet manifest, I thought I should switch to a different job and maybe go to herd goats up in the mountains, something like that. Then I tried harder, and eventually I got it. But it wasn't a pleasant experience the first time. And I think it was more or less the same thing for many people, unless I'm really stupid. And generally, configuration management requires an agent. And there, when we used Puppet, we decided to go agentless. So I don't know if it's really painful or something to have an agent, but I remember a talk by someone from Ansible saying, oh, Ansible doesn't have an agent, but everybody stood up and applauded. So apparently, having an agent is a pretty big deal. And it's resource intensive in the sense that when I do Puppet apply, I see that a lot of things happen, and it's completely okay when I do that on a pretty big virtual machine that has like 100 gigs of RAM, and I don't care if I use 100 megs of RAM for the agent or if Puppet apply takes a little bit of time. However, if I run hundreds or thousands of containers on a machine, running 100 or 1,000 of copies of the agent is not great. And I also and then the traps of configuration management are that the reusability, so the ability to reuse things that have been written by other people, is just as good as the ones themselves. The first time I had to provision ephemeral and EBS volumes on EC2, I noticed that a few people had done that, but it wasn't that great, and then I had to come up with my own. And it's not as deterministic as you think. And this is an example. If you do in a manifest OpenSSL ensure present, then it will install whatever version of OpenSSL is available in the package repositories. It doesn't mean that you will have the version with the latest security fixes. It depends on what's in the repositories. So if you have some machine on a data center in the West Coast, others on the East Coast, other in Europe, and they use different package repositories, you will end up with different package versions. And rollbacks are harder as well, for exactly the same reason. Let's say that in the heat of Harmony, I upgrade everything on my machines to a new version of OpenSSL, which hopefully fixes the bug. But then I realized that it causes some problem with one of our things, and I need to roll back. If I just roll back to that line, it won't change anything. I have to explicitly roll back to a specific version number. Otherwise, it won't do anything. So those are the few of the things where Dockerfile and Docker General want to help. The Docker files, they don't have to deal with the low-level stuff. Kernel, drivers, all that stuff is really irrelevant. You start from Ubuntu or Debian or CentOS or RHEL or Fedora or Arch Linux or whatever you have you and distro, and that's it. You don't need the goodness of configuration management in the sense that you don't need to converge. You're not trying to take a container in an already complex state and bring it to a new state. No, you just start from a clean slate and build on top of that. Change something, okay. Restart from another clean state and build on top of that. And nonetheless, rebuilds are fast because when you change a single line in Dockerfile, for instance, here, let's say I change something here, like I bump to the next version of CouchDB. The Docker builder will be smart enough to realize that all that stuff hasn't changed and it can resume from that point. Because at each step here, it takes a snapshot of the result so that it can resume from that snapshot later if need be. So typically, those steps will take a while because we're downloading like 300 megs of packages. This step will be pretty quick-ish because you're still compiling something, and this will be super fast. So when you change this, you can skip all the downloads and expensive package installation, and later, if you just change your config, rebuilding will be almost instant because all those steps are already done. So Dockerfile is also inheritance and composition, which means that in the examples I gave, I always started from Ubuntu, but I could build my own base image and from that instead. And the learning curve is easy. I hope my examples were convincing enough to show you that you can easily write your own Docker files as long as you know how to write a shell script. You just have to tack run in front of each line, and that's it. However, Dockerfile doesn't deal with the low-level things, as we said, because, well, containers don't care about that. And they don't define resource dependencies. There is no equivalent of before and after. So if you have multiple containers, you have to do something outside of Docker files and Docker to make sure that they start in the right order, that they have access to the right resource, that they know about each other. So, and last but not least, if you have not only one Docker machine, but a large number of Docker machines, Docker itself has no way to help you with deciding what should run where. It's entirely up to you. And that's where Puppet can help. So this is the kind of, if there is only one slide to remember from that whole thing, that would be maybe that one. Before, we were using Puppet to set up hardware or virtual hardware, so to make the machine in a kind of clean state where we can start to run stuff on it, to install packages, deploy code, define dependencies, run services. After, what I propose is to use Puppet to set up hardware or virtual hardware, so it's pretty the same thing, install Docker and run containers. And all the stuff about how we're going to install packages, libraries, dependencies, all that stuff will be kind of handed off to Dockerfile. And the idea behind that is to try to do one thing but do it well. So the thing that Puppet knows to do very well and which is pretty common and easy to find around, because setting up a machine for basic usage, that's something that everybody does. That's the kind of the basic state of things for Puppet, because you start with that and then you add some more stuff. And however, all the things that lie on top of that, so defining how to install packages and all the dependencies and all the complicated things, to try to hand off that to Dockerfiles. So to start playing with Docker and Puppet together, there is an awesome module on the Puppet Forge. So that's how you install Docker. There is a Docker resource, and then you can tell, okay, I want to install a specific version of Docker. I want the module to deal with the kernel, because if you run an older distro, maybe you have a too old kernel that won't run perfectly with containers. So since it was a pretty common problem, the Docker module will deal with that for you. You can indicate which images should be pulled down initially, because even if containers are lightweight compared to bigger machines, a container image can still be a few hundreds of megabytes, so you still have to download that at some point. So instead of downloading that right when you need it, you might want to download that in advance, so that later when you say, okay, I need 10 more web servers or 5 more Redis or something like that, the images are right here and they can start immediately instead of starting with the full download. And you can also run containers. So the same way that you would usually say, okay, I want to start that service or that process, you say, I want to start that container. And you have a little bit more options than you would usually have, because usually if you want to start PostgreSQL database, you will say, okay, package Postgres must be here. Then I have this configuration file that should be here. Then I have a few extra things that should be like this and like that, and that's it. Here, all the resources will be containers. And the example here is pretty complex because it was an attempt at showing all the stuff you can have. But for instance, here, ports is optional if it was defined in the Dockerfile. Links, that's when you want to define dependencies, network dependencies between containers, so that, for instance, this is a slave PostgreSQL server, and it will automatically receive information about the location of a master server, and it will be able to create configuration files for replication. Volumes are a way to do data management. So that's just a bunch of examples of the options available for containers. So a while ago when we started to, yeah?
The question is, so why do you run multiple containers? Why do you have
So why do we run?
why do you run multiple containers? So you also have the Fig, right?
Oh, how does this compare to using Fig? So Fig is a kind of Docker native approach to orchestrate containers, and tomorrow, with a very broad definition of tomorrow, Fig will be able to do more complex orchestration, probably. But today, Fig is limited to single host deployments. So if you have only one Docker host, like only a laptop or only a single server, it's great. But if you want to orchestrate across multiple hosts, it's still a problem. And Fig won't deal with setting up the machine itself. It won't deal with making sure that you have the right version of the kernel, the basic, like the foundations of the machine. Fig won't deal with that. Yes. How does it compare to Kubernetes? You mean Fig versus Kubernetes, or that? So Kubernetes is a project initiated by Google to orchestrate containers together, and I would say there are a couple of big ideas. So let me try to say we can summarize that and highlight the differences. Kubernetes is a kind of container native approach to orchestration. It lets you define pods, and pods are a bunch of containers that share some resources together, typically network resources. So for instance, I can start the web tier like PHP and the database tier like MySQL together in the same network namespace, which means that even though they are completely separated from each other, the MySQL container will not be able to do any kind of damage to the Apache container and the other way around. They will look like they are both running on the same local host. So it simplifies a lot network discovery, service discovery, and network topology. Kubernetes, however, brings pretty different concepts. It's a kind of, it's more kind of dynamic orchestration, like Mesos, and it lets you submit some kind of, let's say, some kind of jobs or things to run to the Kubernetes controller to say, hey, this is a new thing I want to run. Now, it's a new workload, a new application, something new. And Kubernetes will take that, figure out where it should run, allocate resources, and start those containers. In that case, the idea is that you still maintain your Puppet manifest as you used to, and when you want to add new resources, you put those new resources into the manifest, so it's literally infrastructure as code, and then you roll that out to the Puppet master, and it trickles down to the agents, and the agents bring up the containers. I wouldn't be able to say which one is better because it really depends on the kind of organization that you have. If you like the idea of having this central repository that defines everything and is a unique source of truth, it's great. If you like the idea of having a kind of API endpoint at which you can throw jobs and it will schedule them on the cluster, then something like Mesos and Kubernetes might be better. Yes. So OpenBZ used to have dependency on special kernels. Does Docker has the same kind of dependency? So Docker used to have that kind of issues. In the sense, like 1 year ago, you would say you have to run Ubuntu or Debian because you need AUFS, and Ubuntu and Debian are the only distros to ship with AUFS. Today, virtually any distro, any kernel can work. Any kernel means 3.8 and above. And if you happen to run RHEL CentOS 6, the kernel that comes with 6.5 works because it's a 2.6.32, but Red Hat backported everything you need so that containers would work properly. So you don't need that custom weird kernel anymore. Okay, so a while ago, when we started to put Puppet and Docker together, one of the ideas was let's run Puppet inside of Docker. So first, you can easily run the Puppet master inside of Docker if you want to simplify its deployment, but not everybody wants to have dozens of Puppet masters in the network, so I assume it's a kind of specific use case. However, we wanted to use Puppet to build container images. So I have a big library of Puppet manifest to build all my infrastructure, and I want to use that with my container. Can I? Yes, and I will show how. Now, should I? After a while, the answer is probably no. But let's see anyway how it works. Because really, I mean, normally I would tell, no, don't do it. However, you're a Puppet user, so I assume you already have a pretty big library of Puppet manifests and things like that, and you want to reuse most of them. And so this will make sense to you. Not for brand new Docker users, but I'm not talking to, well, not to brand new Docker users who don't use Puppet, but I'm not talking to brand new Docker users who don't use Puppet. I'm talking to people who probably use Puppet already. So if you want to use Puppet to create Docker images, the idea is pretty simple. You write a Dockerfile to install Puppet. So just like we installed Nginx or CouchDB, you install Puppet, and it looks like this. I install wget, I download the package, I install it, and I start the agent. That's it. And then then I start my containers, and those containers will connect to the Puppet master. Then we'll fetch their role and everything to see, okay, what should I do now? And that's it. This is a good idea if you have a mix of VMs and containers, and you want the containers to behave like the VMs. because from an infrastructure point of view, everything is VM, container, whatever, is running a Puppet agent. And so when I want to deploy something somewhere, I don't have to think about, is it a container, is it a VM? No, I just add something to the right node definition, and that's it. That gives us, the point of doing that would be to have VMs that are lighter than VMs. So for instance, if you have a pretty complex stack, because maybe you embrace the microservice architecture idea, or just because your stack grew and grew and grew, and you have so many different databases and web tiers and APIs and everything, at some point you say, okay, if I want to mimic my production setup, I have to run like 10 VMs on my laptop. And well, I can probably do that on that laptop maybe, but that's not going to be a very enjoyable experience. And as much as Vagrant is easy to use to set up one VM, as soon as you start talking about groups of VMs, things get more complicated. Networking is not straightforward and so on and so forth. So with containers, that gets easier. The idea is also that you can get rid of the usual suspects, sshd, syslogd, crond, and so on and so forth. So, and that takes us to another way to deploy and manage the container image with Puppet, which is to make golden images. So instead of having a generic image that just runs Puppet and then turns into what you want, you apply Puppet from the Dockerfile. So the first steps are exactly the same, but here I'm adding my Puppet manifest into my Docker image and I apply it. So I end up with an image which is ready to run and can immediately start my service instead of starting, contacting the Puppet master, figuring out what to do, installing, and everything. That's faster to deploy and easier to roll back, and that's one of the key things. If something goes wrong at some point during the deployment and I realize, oh, I need to roll back to the previous version because the new thing broke everything, in that scenario, I just have to stop the new container and restart the previous image because the previous image is still laying around and restarting it does take 1 second. With the whole scenario, I have to reapply the previous version of the manifest and hope that I wrote my manifest properly so that it's able to bring me back to the previous version. So beyond that, the next step, I mentioned getting rid of sshd, crond, syslogd. The idea is to make containers even lighter so that you can pack even more and save even more on cost and everything, but also separate orthogonal concerns. So that means if I decide suddenly that my logging shouldn't be using plain syslog anymore, but now I want to ship logs to Logly or Splunk or whatever, instead of rebuilding all my containers because I want to change the logging system, I have one container for my application and one container for logging, and I just have to change the logging container without changing the application container. And that ties back to the Kubernetes idea of pods of containers sharing a number of resources. It's exactly the same idea. Instead of having a container that really is a layer that will thump about like a VM that has all the usual services, now you have a group of containers, each responsible for a small different piece, a small different function. This also lets us have different policies depending on whether running in production or on our local laptops. Because maybe in production I want to ship my logs to Splunk, but on my local laptop I just want to put them in some local directory and that's good enough. So, future of Puppet in Docker, there is something that would be pretty interesting. I said that we don't want to run an agent on each container because it's a huge waste of resource, and especially to run hundreds of containers, it's not very nice. However, what if we could run the agent outside of the container? So run only one agent per host, and that agent would be able to take care of all the containers, maybe in rotation, because typically the agent will wake up once in a while and check if there are new manifests and do whatever is necessary. But here it could just do that in rotation for all the containers. And you would have only one agent, but so you would pay the price for the resource usage agent only once, but still deal with the larger containers. Thanks. So if you have cloning devices and teleportation devices, there is a meetup at Braintree talking about Docker and Mesos starting shortly, but I think it conflicts with all kinds of schedules. However, if you happen to be lucky enough to have a Linux clone pass, there is a bunch of talk during the rest of the week about Docker and containers. So about Docker and security, there is a keynote about how containers will make everything different. There is something about Project Atomic, something by Red Hat, a new kind of Red Hat distro specifically to run containers, and more and more and more. Thanks. If you have questions.
Yeah. Is the idea for Docker to run one app at a time in a container?
So
it's like if you have a MySQL database, you run one MySQL and that's it, and your Apache runs in a different container, one app per container, is that the idea?
Oh, so if I have a web tier and a database tier,
yeah, is that the idea?
Do I want to run them both in the same container or in different containers?
Yes.
Depends. The kind of best practice is to have that in different containers, because then you can scale up the web tier without spinning up new databases at the same time, because generally you want to scale things up separately. However, there are some scenarios where it makes sense to put them together. For instance, let's say that you want to deploy hundreds of, well, maybe not WordPress, because WordPress is now something that people know pretty well, but let's say you have a really nice PHP or Python web app, but it requires some really specific database setup, and it's not convenient to have a single central database for all the instances. So in that case, you can say, well, I will put the database and the web tier in the same container, so that when I start a new container, I automatically end up starting a web tier, a database tier, configured to work together. And then I can very easily sell that service as a kind of software as a service thing without having to deal with provisioning and all that kind of thing. Someone did a memcache as a service example with that. It's like less than 100 lines of Ruby, and you end up with a web page saying, hello, you want memcache as a service? Okay, click here, put your email address or something, and a few seconds later, it tells you, okay, your memcache instance is at this host, this port with these credentials, enjoy. And so we did that with memcache, but you can do that with any stack. As long as you have set up the stack to be in a container, it doesn't matter if it's just memcache or if it's something with the web tier, database, caching, and whatever. Thank you. Yes.
What was the GitHub link to get rid of the syslogd when you start up the Docker containers? What was the GitHub link to get rid of syslogd when you start up a Docker container?
Get rid of syslogd and everything.
Yeah.
So it's a blog post that explains that so you don't have to run sshd in Docker containers. It's not really about running or not running sshd containers.
Yeah.
It's about this kind of separation of concerns. As okay, you can have your application, and then logging, remote access, and all those other things can be handled by kind of sidekick containers.
Okay.
And we will post the slides, so you'll have the links later.
The resources that the containers share, are they aware of one another or aware of their host?
Are the containers aware of the other containers and of the host? Not really. It's a little bit like with virtual machines. If you kind of poke around, you can see, well, this is not exactly the machine. I'm not running a full machine. I need something. If they poke really hard, they can see, well, it's a container because they have some clues, some hints, some stuff that you can usually do, but you can't. Like if you try to reboot, it won't work. if you try to tweak some system controls in /proc and /sys, you won't work either. So this will give you some hints that in a container. However, unless the host explicitly exposed some things, the host will be invisible to the container. The host can do that. The host will have a network interface where by default nothing runs. But if the host wants to expose some services to all the containers, you can do that here. There is a pretty common pattern. When you want to start a container that will manage other containers, you can expose the Docker control API inside that container. So it's a little bit like the domain 0 in Zen, to give a kind of parallel. So you can make the container aware of the host and of the containers, but by default, it's as of
Is that kind of what you're talking about by using a data container there for logs, where they're sharing an underlying portion of the file system?
So what about data containers? A data container is a container that will, so let me backtrack like a little bit. There are volumes are a way for a container to share a directory with the host or with other containers. So it's one of those examples of Docker allowing containers to share things. And data containers are containers that exist solely to contain data. They don't run anything, they don't run a process, but they have data. And since you can share volumes between containers, you create a kind of log data container that exists only to contain like /var/log. And then when you start your MySQL or Apache or whatever container, you say, okay, share with the content, with the volumes, of this other container. So now, in your Apache, MySQL, or something container, when you write logs, you write to /var/log, which actually is the /var/log of this other container. And when you want to look at the logs, you start a new container which is just like with a shell and tools like grep and whatever you need to look at your logs. And you also started telling share your volumes with that other container. And then you get access to /var/log of application container. The whole point of that is that if you need special tools or if you're about to run grep, sort something on a very large amount of logs, then first you won't need to install the special tools inside your web container because they have nothing to do here. And at the same time, if you happen to do like a sort on a 1 terabyte file, instead of blowing up the web container because it goes into memory or whatever, you will blow up the containerized container. Thank you.